Good morning, everyone. It's a pleasure to welcome you all here today. How are you all today? That's the enthusiasm you like to hear. This is an important day for all of us, and hence we are all gathered here. It's a significant moment in our shared journey to decarbonize the built environment. I'm happy to see so many of you here today in our auditorium. This is our global headquarters here in London. And I'd also like to welcome the hundreds of people who have registered and who are online today from more than 25 countries. So that's really impressive. The reason we are all here today is to make sure the global importance of this issue is not lost. We are today launching a thought leadership paper that addresses the important question of what is the role of scrap steel in decarbonization of the steel industry. This paper brings clarity to a complex subject at the heart of how we design, build, and shape the built environment. Steel is the foundation of a net zero future. It's strong, versatile, and endlessly recyclable. But it also accounts for nearly 10% of global emissions. Learning how to make, specify, and use steel more responsibly is vital for meeting our climate goals. This publication is a product of an exceptional collaboration between 15 professionals across 15 organizations, representing structural engineering, steel production, construction, consultancy, academia, and more. Formally, it is endorsed by the Institution of Structural Engineers, the British Constructional Steel Work Association, the Climate Group's Steel Zero initiative. The paper is a testament to the power of cross-collaboration, grounded in openness, rigor, and a shared purpose. As we all move towards decarbonization of construction's most emission-intensive materials, the role of recycling and scrap cannot be ignored, but we must look beyond recycling. As our head of climate action, Will Arnold, often reminds me, we can't recycle our way out of this problem. With that, I'll thank you all for being here, and let's begin. Over to you, Will.
Thank you, Yasmin. I'm going to start with the boring stuff, and then we'll kick off properly. Thank you. So for those of you who are with us in person today, we don't have any fire drills planned. So if you see smoke, panic and run out the way you came in. No, please do the things on the screen. We're all grown-ups, we know how to behave in a fire. Grab a copy of this on the way out, I'd suggest. Makes for good reason when you're outside. From a copyright perspective, to the best of our knowledge, we've got permission for all the material that you're about to see today, and this broadcast is presented in good faith. If a copyright holder believes that permission has not been forthcoming, then we can remove the relevant item, or by agreement, an appropriate acknowledgement can be provided to accompany the recording post-event. I always enjoy saying that bit. For those of you listening online, hello. I think at the last count we had 400 joining us this morning online, so imagine a much bigger room than this. For those of you online, you can ask a question at any time. If you go to the bottom right-hand corner of the screen that you're watching us on, there's a sort of grey pop-up for the chat, and in that there's this little blue icon that allows you to ask Q&A. There's also a resources tab, and if you're getting stuck with anything, try logging off and back on again, and if in doubt, get in touch with events@istruct.org. Questions and answers we will keep to the end, and then we'll do a moderated session, both with questions from in the room and online at the same time. So please, people online, get your Q&A in early so we can try and get them into the mix. Final reminder, we're going to put a recording of this online. It should be online on our website within a couple of weeks. We'll send an email around to those of you who registered when it is there so that you can share with others. Please do share this with other people. We hope that the recording of this will be informative for your colleagues, your collaborators, your clients. We won't be sharing the slides around themselves, but obviously the recording gives you everything you need to see. And of course, we would ask that people download the PDF of these documents afterwards and share those with those that you work with as well. This is now live on the website, and you should be able to get it as of now. So we're here to talk about scrap in steel decarbonisation, the role of it, what are the facts for the construction sector, and what do we need to consider when it comes to how we use scrap to decarbonise steel. My name is Will Arnold. I'm Head of Climate Action here at the institution. I'm one of 3 speakers this morning, and so I'll just introduce the 3 of us in turn. I should start by saying that iStructE, for those of you who aren't aware of who we are, we're the world's largest membership organisation dedicated to the art and science of structural engineering. And we have about 30,000 members spread around the world, I think 138 countries. More. And we're a professional engineering institution, learning society and charity. Following myself, Samin is going to speak on behalf of Climate Group, so thank you, Samin, for joining us this morning. Climate Group are an international non-profit. They're 20 years old. They have offices in London, Amsterdam, New Delhi, New York, and Beijing. And they have a number of different initiatives, all trying to drive rapid decarbonisation of some of the world's most important sectors. Samin leads their Steel Zero initiative, and she brings her background in energy efficiency and building decarbonisation to that job. After Samin, we'll then hear from Michael, who's here on behalf of the British Constructional Steelwork Association, the BCSA. BCSA are the trade association for UK steelwork contractors. They're the core members, but they also have a sort of broader membership than that, which includes corporates, industry members, steel producers, stockholders, software providers, and so on. And Michael, you've been around sustainability in steel for quite a long time, right? We've learned a lot from working with Michael on this project, so thank you for being here today to share that experience. We are not the only 3 who fed into this paper, and on the back page you'll see the full list of collaborating authors. You'll see that we represent contractors, consultants, academics, institutions and associations such as my own, and steelmakers, most importantly. There are others who have fed into this process as well, so we thank them for their contribution. And I want to say particular thanks to World Steel, particularly Claire Broadbent and her colleague Barris, who gave quite a lot of time over to us in the summer of last year to help us really dig deep into their numbers to understand what their view of the global sort of steel flows and scrap flows really look like. So thank you, Claire. Thank you, Barris. The brief that we set ourselves for this paper looks roughly like this. There were sort of 3 things that we really wanted to try and dig into. Number 1, we wanted to pick up an objective overview of global ferrous scrap availability and steel demand both now and in the future. We then wanted to understand what that meant to the UK market, but we do so cognizant of that global picture, and I think that's really important that we keep both of those levels of the system in mind throughout these discussions. And from that, we then wanted to bring out recommendations that we could put both to policymakers and those working in the steel industry, working in structural engineering, that will help them use ferrous scrap in the best way possible to help us reduce global greenhouse gas emissions. And that word global is really important with respect to this paper. And it features both in the sort of inputs and outputs, if you like. So when looking at the numbers for this paper, we were considering all sources of scrap steel. So that's not just the construction industry, who use about 1 billion tonnes of steel per year, but also the wider steel industry, which adds another 1 billion tonnes on top of it to give us the roughly 2 billion that humanity consumes every year. We were looking at global data for this global view to help us understand global greenhouse gas emissions. And so while the authors primarily come from a construction background, we do appreciate and acknowledge that the learning points in this paper are applicable to all aspects of steel use across all different industries. With that, I'm going to hand over to Samin, who's going to talk us through steelmaking and scrap's role in that process. Thank you.
Thank you, Will, and hello to everyone. Will has already introduced me, so I won't bore you by saying anything more, but happy to chat later as well. A lot of this information I'm going to start off with, you would already be familiar with, but I think to understand the role of scrap in steel decarbonisation, let's go to the beginning and start with the steelmaking routes and where scrap is used in them. So the paper focuses on the 3 main ways the steel is produced globally, which we are kind of all familiar with, but just to share that again, the most common method of production, of course, is iron making in blast furnaces, followed by steel making in basic oxygen furnaces. This covers 71% of global steel production, and this is what we need to see, obviously, decarbonize as a priority, and this proportion reduce as well. And the second most common is the secondary production method, which is the use of scrap in electric arc furnaces. And that's what we we've been speaking about, is increasing that as much as possible, because we know that scrap-based electric arc furnace production has embodied carbon, which is 30% of primary production. But then, of course, this paper will go into what are the limits around that as well. And then we've also spoken in the paper about the direct reduction iron making, which is emerging as one of the crucial decarbonization technologies that would then feed into electric arc furnaces as well for steel making. So the illustration that we see is almost like a weighted diagram of the input materials, the flow of input materials, which is virgin iron and ferrous scrap, going into different furnaces. It's a common misconception outside of the steel industry that scrap only gets fed into electric arc furnaces, resulting in secondary steel production, and only iron ore is used in blast furnaces, in basic oxygen furnaces. But essentially, we do actually have scrap that is combined with iron in basic oxygen furnaces, and similarly, virgin iron that is combined with scrap in electric arc furnaces. So scrap is essentially used in all steel making. It's extremely valuable, and it's also well utilized. So what we want to look at, of course, is what is the global availability of scrap. And we know that global scrap availability is currently only sufficient to meet about a third of global steel demand, about approximately 35%. And this is purely because scrap is a factor of historic steel production, of lifetime of steel assets, and the rate of recovery of end-of-life steel products. So what we wanted to look at was how much scrap is actually available globally and how much is recovered and recycled. So we've come to the understanding through a lot of review of past publications. We've referenced World Steel's 2012 paper in this, but also tried to look for more recent publications that will either substantiate or contradict the findings, which is at a global level. But in all, what we've understood is that 80 to 85% of scrap that's generated globally is actually recovered. And of what's recovered, most of it is recycled, because the inherent nature of steel, of ferrous scrap being magnetic, it's easy to recycle what you recover. But of course, we do understand that there are piles of scrap available, or probably around somewhere in the world, which is uneconomical to recover as well, because we'll have steel buried deep underground in foundations, in sunken ships, which is also kind of contaminated through use in applications such as the nuclear industry, which is more challenging to actually recover and reuse. So it's never going to be 100%, but 80 to 85% gives us a good sense of how valuable scrap is and how much is actually already being recovered and recycled and used within the steel industry. So when we look at the future projections of scrap, of course, there are gains to be had, because as a society, we are becoming more efficient with the way we do business, with the way we recover things, with the way we use the resources available to us. So there will be certain efficiencies gained through certain improvements in scrap recovery and recycling as well. And also based on historical trends, we could make a judgment on how much steel will come to end of life and will be available for recovery. So through these projections, we could say that by 2050, which is one of our climate target dates, that the amount of scrap available could increase from current levels of 35% up to 50%. But we know that it's not going to be much more than this, at least by 2050, because global steel demand will also increase. So the ratio could change. There will be an increase in scrap percentage in the steel making, but it's going to remain at that 50-50 level by 2050. So what we're trying to say is that in this paper, which is an extremely useful, updated literature review of scrap availability, the recovery rates, and the role of scrap in decarbonization, there are some, of course, nuances and uncertainties that we need to be aware of. And one of the things that's always very challenging is how do we actually account for how much scrap is available? How do we track the material flows of scrap and steel use? That's always going to be a challenge because we're looking at global data. There's going to be variations by sector and regions where scrap is generated, recovered, recycled. Some countries might not do it in as much of a sophisticated way that they can publish and share this data. And we also know in some countries there's a large informal sector of scrap recycling, again, where it might be difficult to really trace and track the amount of scrap available. So, of course, all of this has been considered in the review of the paper. And what we also understand is that while scrap is highly valuable and highly recycled, we have, of course, two main types of scrap that we talk about: the pre-consumer scrap, which is scrap generated during the manufacturing of the steel products, and the post-consumer scrap, which is after end of life of the steel application. And we can say roughly there's about 50-50% of scrap generated in pre-consumer and post-consumer. Now, most of pre-consumer scrap is recovered and recycled because it stays within the steel industry, the steel supply chain. But it's hard to really understand and track the amount of that scrap that's available post-consumer. And we've taken all of this into account in the study that's been done for this paper. So, of course, those are the uncertainties around pinpointing the exact level of scrap availability that is recovered, but that's why we've gone with a range, a percentage range of 80 to 85% of scrap being recovered annually, and most of this is recycled and used. And then, of course, how scrap is recycled and how the quality is maintained in that recycling dictates how it's used within the further steel making process, its reproduction for its new life and new applications. And that, of course, also then affects future recyclability and use of scrap. So to conclude, this research on scrap availability, its role in steel making, before we move on to the low carbon steel making and recommendations section. The first consideration is that we have learned that scrap is extremely valuable, it's constrained, as well as a highly utilized resource. And we've also concluded that the rates of scrap recovery is not going to significantly increase. It will increase a little bit, but not significantly. So we can't substantially just increase scrap-based steel making to solve the problem of decarbonization in steel making. We have to look at all sources of steel production, all methods of steel production. That's the primary steel making that uses virgin iron ore, as well as secondary steel making with scrap use. And that is why throughout this paper we're calling it the dual decarbonization approach. And that is what we're going to be referring to and talking about a lot more when Michael also takes the stage just now. So thank you very much.
Thank you, Samin, and thank you, Will, and thank you, iStructD, for leading this initiative. Yes, I've been involved in this for some time, about 25 years, I would say. And I think the complexity of the subject and the work done in this report kind of belies the concise version you take home with you today. Anyway, my bit is all about low carbon steelmaking and what we recommend, and I'll come on to that. I just want to start with, and we really don't have time to get into all this. This is a whole kind of 3-day conference, isn't it? But, you know, there are lots of low-carbon steelmaking technologies under development, and they cover existing blast furnace or integrated production, so carbon capture, use and storage technologies, some skepticism about when they will be commercially viable, but government is pushing this. In terms of scrap, EAF production route, we're looking at lower carbon electricity and incorporating low carbon DRI into that process route. And then there's a raft of other new and upgraded ore-based technologies. These are just really a subset. But just to really say, without getting into the detail, there is lots of work in this area, lots of it certainly in Europe. And this is obviously a classic example. This is the hybrid facility in Sweden, where they are already well advanced with hydrogen DRI EAF technology. So it's coming. It's going to take time. This is a massive industry, and it's going to take a lot of money. I've seen various estimates of 1.4 to 4.4 trillion to decarbonise the global steel industry. So it's certainly a tall order. So that's all I'm really going to say about the technologies. Instead, I'm going to focus more on specifying and incentivising low carbon steel, particularly in the context of this paper and scrap. I think when we talk about low carbon steel, I think it's worth just pausing to think what exactly we mean here. What it is and how do you specify it. It's not easy. Low carbon is a relative term. What do we mean? Low relative to what? And there are no agreed definitions. There are various standards and approaches, but nothing kind of universally or globally agreed yet. Certainly current assessment approaches, there would mainly be the CEN ones, also the ISO ones. So the assessment methodology certainly we use in construction. The upfront carbon emissions, so A1 to A3 in common parlance, clearly the EAF emissions are much lower than the blast furnace route production. Won't get into this either, but this assumes all scrap is recycled carbon-free. There's a whole debate around Module D and other things, but we won't get into. But clearly on the upfront carbon emission side of things, there's a significant benefit in terms of upfront carbon emissions for EAF-produced steel. So what's the best approach to specify that within a global context? And I just re-emphasise, as Will's already said it, we're looking at a global context here, not a project context, not a national context, but a global one. Steel is a commodity product. It is traded widely globally, and clearly climate change is a global issue. So that's the context for this under publication. So we refer to this commonly. It's in the report, and it's been used by a number of organisations. This is sort of the sliding scale approach that we use to demonstrate the dual decarbonisation approach. The y-axis is the carbon intensity of the steelmaking, and the x-axis is the scrap input to that. Every dot on there is a steel mill somewhere around the world, and just looking, the grouping towards the left is the blast furnace, the primary production route. Typically 0 to 25% scrap input, and the right-hand cluster is the EAF, typically sort of 80 to 100% recycled content. In the middle, we're seeing more and more of the sort of more hybrid technologies, particularly say in the US and the Middle East. So these would be DRI, EAF, scrap sort of hybrid technologies. But the important point to note, I think, on here is that the cluster to the left represents something of the order of 90% of global carbon emissions from steelmaking, whereas this cluster to the right is probably only about 10%. So the obvious conclusion then one might deduce from that is we need to shift to the right and move to higher percentage scrap and delight your client on a project with a low embodied carbon project. But of course, as we've heard, scrap is a constrained resource, and quite simply, we can't do that. There isn't enough scrap for us to do that. Even if we increase 80, 85% up to maybe 90%, all we're doing is shifting all those dots a little bit to the right. It's not going to solve the global challenge. So instead, and this is what the approach we've adopted, we're more thinking, instead of moving left to right, we're moving from top to bottom. So as you can see, there's a reasonable variation if we look at a sort of a vertical line on there. So there is variation, and what we're encouraging is all those mills to decarbonise, so to move downwards on this graph. I would accept that there are some issues with scope and measurement variation on this, but in essence, that's what we're proposing as this approach. So we're asking all steel mills, irrespective of technology, to decarbonise. That's the only way to solve this in the context of global steel demand and global scrap supply. And of course, this is really the manifestation of that in this context under responsible steel. Criteria 10.6, it's also the approach adopted in Steel Zero, and you can see the different progress levels there which are adopted both in responsible steel and in Steel Zero. But it's not, this approach isn't ours really, and it isn't just Steel Zero. There are many other organisations supporting this same approach. Probably IEA probably started it, but new standards, we've seen the German standard less and the new Chinese standard, are all basing on the same sliding scale or dual decarbonisation approach which we're advocating. So really, just to conclude then, without getting again into the detail of the technologies, so what we're looking at is decarbonising both primary steelmaking, so through increased and low or zero carbon iron, could be DRI, could be other technologies, and then in terms of the secondary steelmaking, we're talking about decarbonising the electricity used to power those furnaces, and we're talking about better segregation and sorting of scrap so we can maintain quality and maintain and hopefully improve slightly those recycling rates. And this is the dual decarbonisation approach that we're advocating in the report, and many others are advocating around the world. So I'm sure loads of questions coming, but I'm going to hand back to Will, who's going to wrap up with some of the key messages. Thank you very much.
So the paper contains 5 key messages, which are at the start of the paper, even though they're at the end of the slide deck, and contains a number of recommendations that we're proposing both for policymakers and those working with steel directly. I won't go through, I'm not going to read them all out verbatim, they're quite long, but just to pick up on the really key points within both the key messages and the recommendations. Number one, we recognise that there is a need to absolutely maximise the recovery and recycling of scrap in this industry and in the steel industry in general. It's got to stay as high as it can, and if there is room to improve it, we would support that. It needs to be as high as we can possibly see. However, we must recognise that scrap is a constrained resource. It's highly utilised. We're talking 80 to 85% utilisation, and we recognise that that number could never be 100%. There will always be some scrap that is economically unrecoverable. So that gives us a bit of play on that number, but there's a limit to it. We recognise that global scrap availability is enough to satisfy about 1/3 of our current steel demand around the world, and that percentage will rise with time. It's expected to rise, but only to, at most around the sort of 50% mark, as Samin said. That means that by mid-century, half of all steel will still be produced using iron. We can't get out of that. Therefore, we can't just rely on recycling to get us around this. We have to do something about primary steel making as well. And that is why we're calling for this dual decarbonisation process, because decarbonising scrap-based steel making and iron-based steel making both need to happen in parallel. That takes us to key message number 4. This means significant time and investment at a national scale. We can't get over that. The numbers that Michael said are very big numbers, but this is what's needed if the steel industry is to decarbonise. And the 5th and final key message is that in terms of what the construction industry can do, and I'm aware that most people listening today probably work in construction rather than car making or fridge making or something else, what we can do is to support steel recovery and reuse. We've got to do our part to help keep that scrap recycling percentage as high as we can. We should be using steel as efficiently as we can. Scrap is constrained. Steel is a valuable resource. We need to treat this as a valuable material. use it efficiently. We need to be designing for reuse. And when it comes to specifying our steel, we need to be specifying it from suppliers who are aligned with this way of thinking, who are aligned with the dual decarbonisation approach. And Michael showed some of the initiatives that align with it on the screen before. And I would expect that there are other suppliers out there who would tell you that they're working to decarbonise primary or secondary steelmaking as well. The recommendations at the back sort of dig into a bit more depth. I won't read them all out, but I think the three key things that are repeated within the recommendations page, number one is about education. So this is about helping our clients to understand that there is this tension. There's this real tension between getting the lowest carbon project we can and decarbonising at a global scale. And it's not obvious how you do those both at once, but we need to work out a way to do it. Number two, obviously what comes up again and again through these recommendations and through the paper is this need for dual decarbonisation. So whether you're a policy maker and therefore writing policies that align with that, or you're a steel specifier and therefore you're specifying in a way that aligns with it, or you're a steel producer, you're in supply chain and you're working out how do we support that dual decarbonisation approach, how do we get our bit of the steel industry to decarbonise, whether you are primary or secondary. And then the third thing that repeats is this need to treat steel as a valuable resource, use it efficiently, design it for efficient use. With that, we've got about half an hour or so for questions. I'm going to invite Michael and Samin to come and sit at the front so you can lob questions at them, not just me, please. Those online, please do put them through to the chat and it will come up on my screen so we can intersperse some of your questions with questions from people in the room. And for those in the room, if you could just wait till the microphone gets to you before you start so that those online can hear as well, that'd be much appreciated. And maybe if when asking a question, you can tell us who you are and who you work for, just so that everyone's got a bit of context. Does anybody in the room want to go first, or do you want to hand over to the folk online? Any hands? We've got one at the back in the middle.
Hello.
Hello.
I'm Ben Gardner. I work for Hain Tillett Steel. The dual approach is interesting, but ultimately the vast majority of the carbon footprint is caused by primary steel making. And a lot of those technologies which were shown on the screen are not actually new. They've sort of been established for quite a long time at research scale. And it seems like maybe the barrier here isn't technological, but economic. And a lot of steel makers are keeping these things kind of bubbling away. Sometimes I think, you know, just when everyone talks about sustainability, these things get sort of wheeled out and we're all shown the pilot plant again, but they always seem to be a few years away. And perhaps it has to come from legislators, but from a specifier's perspective, it feels like you can't specify something which isn't available. I guess it's not really much of a question. Any thoughts on that?
Any thought? Yeah, always finish with any thoughts. Do either of you two want to go first? Samin?
Yes, I'm happy to go first. That's a very valid thought that you've just shared, and that's exactly what we see in the steel industry is there is the technology available. It's how do you actually implement it, and a lot of it does boil down to the economics, the commercial viability, the costs associated with it, the time scales and everything, which is why at Steel Zero specifically, we are a demand-led initiative. So there are demand-side companies that are making these commitments to procure the lower emission steel that meets the progress level 2 that was shown on the graph earlier by 2030. And then net zero steel by 2050. So it's bringing that demand signal very early to show to the steel industry as well as policymakers that there is demand, and as long as and we are there to support the industry to decarbonize. So we need this ramp up of incentives and policies and regulations from the policymakers side, as well as the investment community, and obviously the steel industry as well playing its role in all collectively working towards that. And dual decarbonization is extremely important because a lot of effort especially is needed on the high iron ore side and decarbonizing iron making first and foremost.
Yeah, I just to add to that, I think that your statement about most of the emissions from steelmaking are from primary steelmaking is spot on. My numbers are it's 90% due to the primary steelmaking and only 10% due to secondary. And therefore that is where, the real sort of input of money and time and resource needs to be. And what I'd say is that what we hope this paper does is help to bring a sort of slightly more consistent message about what we're asking for. Because if everyone is saying, whether you're a primary or secondary steel maker, we need you to decarbonise the way you make steel, rather than talking about shuffling scrap back and forth across the globe, then maybe we will start to make some traction on this. You're right, the technologies exist, but they need serious money going into them. That needs demand signals that are really clear from the industry, and we want to see both of these decarbonised. Thank you. We've got another one back right. Thank you.
Hi, Nick Cole from Robert Bird Group. I guess a related question to that. You presented the graph with the sliding scale with the different decarbonisation levels, obviously targeting, dropping down the scale to low carbon, but comparing that against the graph with all the dots on it, essentially more or less everyone in the industry is sat in that upper tranche of the scale, with very few below that. In presenting that sliding scale, is the guidance on what's currently available? Because I guess the risk is, this is our new approach. This is how we should be specifying. But the reality is, if you do specify it, it's not available there. And I guess how is that information then fed back to the specifiers to tell us what is available and what we can be specifying?
Michael, do you want to talk about availability of, I guess, the responsible steel level 1 steel, for example?
I think it's a fair point. I think we probably do need some better guidance on that. And I think, as I mentioned, there's certainly an issue of exactly how those dots are measured and where they sit on the graph currently, because there's some issues around scope and measurement of that. But I don't think, that the approach, the sliding scale approach, let's call it, is for me certainly theoretically the best approach. I think there are still some issues to resolve and discuss regarding timelines and maybe also regarding what the actual progress levels are in different nations and different regions. So I think that's probably next steps for us and Steel Zero to think about that. Obviously, I'm preempting questions on the current situation in the UK, but we need to adopt this approach, but we need to set those progress levels at a time frame and at a level which is commensurate with current developments in the UK. And in a sense, politics have sort of overtaken the carbon argument. So just reiterate again, the scope of this is global carbon. We're not trying to address the more difficult, shall we say, political and economic arguments occurring in the UK at the moment.
Yes, and I'd also just add to that point. With specifying, and of course, there's a tension. I think Will alluded to it as well about how do you specify for a project to meet lower carbon today versus what's actually available today, and how is that then contributing to global decarbonization? And this is what we have to all really understand deeply and then talk about in project development discussions, between clients and specifiers and contractors and everyone, because ultimately there is not a lot available today, and what is available today is, yes, could be lower emission, but it's still got a lot further to go to decarbonize. So we are talking about supporting the steel industry and supporting producers that have started that journey. And specifying or setting strategies, again, we have to talk about time scales. So this is not for projects being implemented today in the next 2 years, 3 years, but how are we thinking forward to set a strategy that, we're activating the supply chain for future as well. And I think that's something we need to think about in specifications, is a small proportion we could work out for now, for projects right now, and look to identify where that's available, but broadly keeping in mind that we are also starting on that journey. So how are we supporting the steel industry to decarbonize? How are we specifying for future carbon reduction as well? And that's something that we need to all be thinking about in discussions today.
Thank you. Another question in the room, please. Down at the front right, Brogan.
Thank you. Hi, Brogan MacDonald, Head of Sustainability at Rambo. Firstly, I just want to say I'm so excited about this paper. It really made my day to come out, because I've been chapping on to clients about this for a really long time and not had much proof of my statements of why specifying EAF or highly recycled steel is an inefficient means for global greenhouse gas reduction. So I'm really excited, and I think it's great for a lot of people who have been trying to advocate for this. A question for Samin and Will. Ramble have been members of Steel Zero for quite a while, and we've been going through that journey of adding essentially the dual decarbonisation pathway to our specifications. I think it's really hard to speak to our clients and contractors who are not upskilled on this yet, because it's quite complicated. There's so much geopolitics. Understanding all these numbers about scrap is really hard. But to progress this on a wider scale, and we've got lots of engineers tuned in, perhaps from iStructE and ICE, are we looking to kind of put this message for specifiers, which we're doing on Steel Zero, out to everyone who are not members of Steel Zero? Is this going to be a guidance for all engineers that work in the built environment to specify this way? Will it be an open source, is my question.
Yeah, I mean, I'll start on behalf of iStructE. You know, the reason the institution is endorsing this paper and has funded this work to happen is precisely for this reason. You know, we want to see all of industry, whether it's engineers who are members of ours or not, doesn't really matter to us. We want to see the whole industry get behind this message. We want to see steelwork being specified in a way that aligns with dual decarbonisation. We want to see engineers having conversations with their clients that talk about this difficulty at the start of projects, sets carbon limits on projects at an appropriate level, tries to understand how you meet those through the use of steel in a way that reduces global greenhouse gases, not just the project's greenhouse gases. Yeah, absolutely. We want to see this across the whole industry, for sure. You know,
Yes, exactly that. I think we'll definitely, now that we've got this paper, we've got a good reference source as well, we can definitely look to, and in speaking with you and others who are involved in these conversations and who are members of Steel Zero, with BCSA as well. I know we've been speaking with Michael and I about the specification, how do we actually use this in specifications? So that is something that, it's always a challenge about how you communicate it so that, you know, an audience or like somebody who's reading it from any sector, any part of the world can actually get the same message out of it. And that's what we need to obviously carefully curate as well in such an open source material. And we'll definitely work together to have that available now that we've got the scrap paper published.
We'll take one more in the room, then we'll do a couple online. So back left, Alexia.
Thank you. Alexia Laird, Sustainability Director at Landsec. I suppose more from a client point of view, and it's probably going to repeat a few of the questions that we've already heard with regards to understanding how we put this into practice, but I'm keen to understand, we've fallen foul in the past of setting the targets which have led to market distortion by going by high EAF, so that's clearly not the way. We've spoken with HTS in the past about looking at DRI-based specifications, again, clearly not available in Europe. What role can we as clients play without then, again, going down that market distortion route? I think what I'm struggling to understand is it's such a concrete, it's a tangible decarbonisation pathway that we can have direct impact on. Steel, because it's so national level, it's so geopolitical, I think I'm really struggling to understand as a client what role we can play and how we set the targets that will then lead to the right specifications.
It's tricky, isn't it? Because you're in a position where you want your project to be as low carbon as you can, but you don't want to do something that's not going to help at a global scale. And the worst thing you can do as a client is to incentivize the opposite behavior, pat yourself on the back, think the job is well done, lower your carbon targets for next year as a result, and just sort of continue this cycle without seeing anything change in terms of the global emissions problem that we have. I guess the two things I'd say firstly is that we were having really similar conversations on this topic a year and a half ago on concrete and on GGBS, and the feedback was the same, right? It was at this point in time in the UK, the only way we can reduce the carbon footprint of a concrete mix is to bung as much GGBS into it as we can, and now you've released a paper, iStructE and partners, that tells us that we shouldn't do that. It doesn't help at a global scale. What on earth are we going to do? And I'd say that what we've seen in the last 18 months, and that's been really positive, we've seen, you know, a sort of acceptance that this is going to take some time, that other technologies need investments in, and that we need to drive that behaviour, but that we're only going to get any of that if we are upfront and honest with ourselves about this problem in the first place. That's not the problem. So I think we're in the same place on steel. I guess the problem you're alluding to is that to decarbonise steel at a scale that it affects all projects is going to take a lot of money, it's going to take a lot of time. And at the moment, my understanding of the only hydrogen-based DRI steel making in the world is that it's all been earmarked by Volvo, I think, to put into their cars. So we won't be getting it on a London construction site next year. That's true. But we're not asking in this paper for you as a client to say, well, I want the lowest possible carbon primary steel on this project today. I want that hybrid steel or nothing else. What we're asking you as a client to do is recognise that on that graph, there's a sort of line of average. There's better and worse for any given percentage of scrap. And so ask yourself on your projects, how can you start to get below that line? And what can you do to incentivise one of those dots that exists in your supply chain to try and push itself down rather than just thinking it has to push itself to the right? And if you can do that on every project, and if you can convince your competition, collaborators, call them what you want across the industry to do the same, then we would expect to start to see things drive down. It's a difficult conversation, but I think it's good that we're starting. That's the main point, right? I'm going to take a couple online, just so we don't forget about our hundreds of people, and then we'll come back into the room if that's okay. I'm going to put a couple of questions together. Michael, I might ask you to go on the first couple if you can. One, to summarise, is, are there technical reasons why scrap can't be recovered? So why are we at 85% and not a higher number? And the second question then is, should or can the UK fully rely on scrap to decarbonise itself, to decarbonise our territorial emissions?
Sure. Okay. Well, I think Samin covered that to a degree, in that clearly there is some construction, particularly applications, where it's very difficult to recover, notably foundations and tunnel linings, etc. Also some radioactive when they're too contaminated to recover. So yes, there are some situations, probably more so in construction than in other sectors actually, where it is currently uneconomical to recover. The second one again, Will, sorry.
UK decarbonisation reliance on scrap.
So yes, I mean, I can't remember the figures off the top of my head, but something, as most developed economies, the UK has sufficient scrap to maintain its current demand purely through scrap. I think we currently generate something between 10 and 11 million tonnes. Bill might be able to correct me if I'm wrong. But that is certainly sufficient to fulfil the demand currently for domestic production. So I don't think we have any worries on that regard. I think that's all I want to say. There's lots of questions, no doubt.
There was another sort of similar question about, is the approach able to cover the same demand as BOF? And I think we've sort of covered that. And we've already said that at a global scale, the numbers we had on the slides are still true about the sort of 30% from scrap, 50% and so on. I think the other thing I'd add is that, we recognise that, okay, at the moment, the most referenced method of decarbonising primary steel making involves electric arc furnaces, and it involves feeding low and zero carbon iron into those furnaces. And so a strategy that involves moving towards EAF can be seen as the first step towards decarbonising primary steel making. I think the important thing is to not rest on our laurels if we do move over to EAF. So if the UK is going to move to scrap-based EAF to keep all of our scrap within the UK, fine, but I think we should recognise that in the future those electric arc furnaces may also be fed with zero carbon iron, perhaps from the same place we currently feed our blast furnaces with iron ore from. It might be coming from overseas. We've had a question about should we be designing using generic carbon factors for steel? I think this is one for the two of us, Michael, probably. Do you want to go first?
Yeah, I mean, it's a tricky one, isn't it? Because the approach we've described here, in my opinion, is good for comparing steel company A against steel company B. It's less helpful for you as clients and designers in comparing, let's say, steel versus concrete or timber on your project. So yeah, that is a challenge. And then the question is, what do you do at the early design stage? Now, the approach that Will and iStructD have adopted, rightly or wrongly, is to take a UK consumption market average, which I calculate, or BCSA calculates, and that's the value you'll find in the iStructD guidance. So, I mean, it's well, Will can answer that really. I mean, it's difficult, and steel is weird, isn't it? Because we have such polarised values, don't we? down 0.3 up to 2.5. So what does an average mean? You can't really specify the average anywhere. So it's a pragmatic solution unless Will has a better explanation. But it's not terribly satisfactory, I don't think, for steel. And I think ISRUCT do recommend you don't just pick that average value, you do look at a range. And I think that's the current guidance, isn't it?
Yeah, so what we recommend designers do at the early stage with all materials, not just steel, is to use these generic factors at a sort of locally appropriate level. So if you have if you're based in the UK, you can use a UK consumption factor. That's what we put into how to calculate embodied carbon. If you're based in Malawi, maybe you don't have that. Maybe you need to look to see if there's something for East Africa. Maybe you have to look at a bigger scale than that. You use that for early stage decision making. The reason why we rely on this is we know that we have a mixture of steel sources coming to our sites. Across the industry, we're trying to make the right decisions. But we also say that as soon as you've locked in a supply chain, you do want to start looking at specific carbon factors. And I don't think what's in this guide changes any of that advice. And like I say, that's sort of material agnostic. I'm going to have one more online question, and we'll go back to the room. And a reasonably quick one from somebody based in Malaysia saying, how does transport emissions factor into all of this? Do either of you want to go, or should I?
You go.
I'll go.
I'll supplement
Basically, the short answer is that in terms of what we have looked at, we've just been looking at the amount of scrap that features in recycling and steel production, and therefore the big picture about how we use that resource. We recognise that transport emissions may decrease if you are currently taking scrap from one country, shipping it to somewhere else to recycle it, and then buying the steel back from there to build in the first place. You could get round all of those emissions by just recycling it in the place it's generated. And of course, that's one of the benefits that would be present on a global scale if the UK, for example, moved to recycling, is we emit those emissions. Because most of our scrap at the moment, I think, gets recycled in Turkey, South Asia. It travels quite a long way. So that is a real saving that could be had. But that doesn't, again, this at the global scale, this is about how much scrap exists around the world. And therefore the need to, these are small numbers. Transport emissions are small numbers in the scheme of this. This is about trying to decarbonise the big picture. Okay, we'll go back to a couple in the room. We've probably got quite a lot of hands, so let's start at this side and we'll come across.
Hello, Dominic Munro. I work at Arup. One of the things I do is look after our steel specifications, so I'm really interested in this. First thing I want to say is thank you very much to the institution and all the authors. This is really welcome. It aligns perfectly with what we've been talking about as well, like Ramble have been saying. So thank you. This really puts a lot of good weight, and there's a really great consensus across all the different people you've got involved in getting this, like the GGBS paper. So that's great. I wanted to ask a question before I forget about what you think about Responsible Steel Progress Level 2 and how we actually certify that, because that seems to be one of the sticking points in the specification. If you want to go vertically down using those progress levels, it's getting some sort of paperwork that says that that's being supplied. I would like your thoughts on that. I also would just like no, it's not quite an advance, but we have, on the question of how you do the calculations, there is hopefully a paper coming out in the Structures Journal later this year, which various authors have contributed to, which will address this question about what you do for either at the early stage, what generic values you should use, or how you compare two different EPDs, and what you do with the different scrap levels, based on this principle of the constrained resource that you've identified here for both scrap and GGBS. So that's going to be another piece in the puzzle, I think. But my question is about the question that's coming also from the clients: how do we specify, and what do you think we're making any progress to be able to get to a progress level 2 in terms of availability as the next step?
Smeen, do you want to start on responsible steel?
Yes, I can start on that. Yes, if you look at the certifying to responsible steel progress level 2, I think essentially I mean, yes, one way is, if you go through the whole certification process under the Responsible Steel International Production Standard, and then you've got the paperwork to back it if it falls below progress level 1 or progress level 2, or whichever progress level. But essentially what we need is data from the steel makers, because that methodology is at crude steel production. Now, a lot of, working with your clients, of course, want to know what is the steel product emissions, like what's the emissions of the product that you're getting in hand, and there is, of course, a difference in the boundary of those calculations. So the responsible steel approach is up until crude steel production, so the first point of steel making, and that's the data that we need from steel makers. So essentially what we're asking for is more transparency and disclosures, starting from the steel makers and then being available all the way through the downstream manufacturing actors, all the way to end users, about what is the emissions intensity of that steel coming out of the steel making site, and then of course what's the percentage of scrap share going into that steel making. And then at least the approach that we use under Steel Zero is, if we have these two data points from steel makers, we can see where it fits within the graph. Also, what we recognize is that if you're looking at the global average today and the need to reach decarbonization progress level 2, that's roughly a 30% decrease in emissions. Of course, it'll be different for different sites, but average 30% emissions decrease by 2030 is what we're saying, to reach below, or not any date, to reach below progress level 2 from current global average. And so it's, which steel makers or what processes are being implemented that can actually start to result in that decrease as well. But I think most important is to look at and to ask for that data, the transparent data from steel makers to start with.
Did you want to add, Michael?
Just a quick add then. So I think, Dominic, one thing we are starting work on is, conscious a lot of people use EPDs, and they generally pluck a A1 to A3 value for global warming potential there. But we recognise there's probably a need to standardise how carbon intensity and recycled content, in alignment with the Responsible Steel Standard, is put onto EPDs. So you can pick up an EPD instead of picking up the number, pick off to see where you fit on that sliding scale. So that's something we're working on. We're actually meeting after this today to start that discussion. But I think that would be really useful because, EPDs, there's a lot more and more coming. I'm sceptical of some of the quality, but I think if we can put in some consistency regarding measurement and see where you are on that graph will help you specify, Landsec as well, I think, help you to specify more in alignment with the approach we're advocating here.
Thank you. Another question in the room from the side. We've got about 15 minutes left, so if I can ask those asking to keep them short. There we go. Yeah, thank you.
Yeah. Morning, everybody. I'm Bill Firth from European Metal Recycling. Thanks very much for the report. We really do welcome this, and although Will, we don't agree with the final recommendations, I think it's good to have a discussion and debate about this. I think our view is that you should specify recycled content, because we think that will incentivise the upstream recovery of additional ferrous materials. We think there is significantly more than what was specified in the final report, and also incentivise the downstream production of higher quality steels, particularly constructional steels, which will then, we think, will accelerate the decarbonisation of other primary steel making processes as well. But my question was really around, we think it's quite a big miss that you haven't picked up any of the sort of sustainability impacts associated with primary versus secondary steel production. I just wonder if the panellists had any thoughts about that and whether that would be covered in any subsequent report. Thank you.
Thanks, Bill. So I'll happy to say this. So the first thing I'd say, Bill, is that the paper is clear that in terms of scrap that is utilised, we do need to keep that rate as high as we can. We recognise that there is a bit of room to increase this, and that would be a good thing. If that 85% figure can creep up to 90, that is good. But we also recognise that's 5% difference from the bit of the steel industry that has the smallest impact on emissions currently, and it's dwarfed by the need to decarbonise both primary and secondary steelmaking. I think the evidence in the paper is pretty clear. And I think what's also quite telling is that the Chinese industry are also getting behind this. China creates about half of the world's steel, right? And when you operate at that scale, you have to take the same mindset that you would have at a global scale. And China recognise that they can't just rely on hoarding all the scrap and recycling it, and therefore they've gone down this dual decarbonisation route. And we provide a link to their documents to do that in the paper under the precedents section. In terms of, so I've forgotten what your actual question was now. I was too busy responding to your first points. Yes, sorry, thank you. So, no, the paper has focused solely on greenhouse gas reduction. It's been a 1.5-year process to get our consistency around that. It's been a pretty big bit of work just to get on that. There are a myriad of other environmental impacts, both related to recycling and primary steel production, for sure. Taking iron from the earth, transporting things, melting iron and steel at the 1400 degrees C has some pretty big impacts. But we haven't tackled that in this report. We've focused purely on carbon emissions. Yeah. Another question down the front.
Morning, everyone. I'm Ben Cunliffe. I'm Commercial Director for British Steel. As you can imagine, I've had an interesting few weeks, to say the least. So first, congrats, Will and the team. I think it's a fabulous paper, and British Steel do support the key messages, particularly with the view to being very careful as to what you specify, because specifying low embodied carbon steel makes no difference to global CO2. And actually, specifying low embodied carbon steel today means imports. Let's be clear about that as well. They're not available in the UK today. Low embodied carbon steel is at least 5 years away. And a little update really in terms of a reflection. I think it's important that I give people a reflection as to where your domestic steel producer is. So we've all seen the press a few weeks ago, and I think that it's fair to say that the likely next step for British Steel is that you good people in this room, and there's 65 million people in the UK, will all become shareholders in our company. I never quite thought I'd see my career out as a civil servant, but you never know. So it's very likely that we'll step into public ownership, and I think the importance of that is as follows. So the government announced in January of this year a steel council, a UK steel council, and the objective of that UK steel council, which involved industry experts, it was chaired by Secretary of State Jonathan Reynolds, the business secretary, as well as John Bolton, who's head of MPI, as well as the steel producers. And the government said right at the very start that decarbonisation must not mean deindustrialisation of the UK. And if we're not careful, people specifying low embodied carbon steel today, that's exactly what you'll get. You'll get steel making going to China, and believe you me, we were hours away from that very issue happening, our steel making going to China. So we need to wake up and have a real discussion in the UK as to what do we want to do in terms of UK, both in terms of UK steel making, UK manufacturing, and our approach to decarbonisation. Because I've been saying this for a while, and Samin, you'll smile, we need to be fully aligned with what government policy is suggesting with UK construction, which, by the way, pretty much most of our steel goes into the UK construction sector. If there's no demand, if all the demand goes overseas for low embodied carbon steel, the government's wasting your money by paying for British Steel and by investing in British Steel. And the final thing to say is, in the industrial UK Steel Council, the key objective they're looking at is they're writing a paper to determine what the future of steel making in the UK should be. They're looking at, should that be primary steel making? Should that be primary steel making with a form of DRI, with a form of these other technologies? Should we move to electric arc steel making? Our shareholders, who are currently shareholders but not likely to be much longer, had decided to go down the EAF route, which was 5 years away, which was fine. But the government have realised actually steel making is about national security. It's much more than just about decarbonisation. There's some very, very important things at play here, and therefore there's a really important debate going on. And believe you me, the UK construction sector will absolutely be at the forefront of that debate as to what we want to do with the UK steel industry. And you know, so I just really, it's not a question, Will, it's more a pause of reflection. So we absolutely support the paper, but we've got real questions to answer as to what we want with our UK steel industry. and how that feeds into a more prosperous UK economy and UK construction sector.
Thanks.
I'll take any questions after, by the way.
We've got a question from on the right, please, straight in front.
Hi, my name is Matthew Wenmouth-Smith. I'm a consultant. I was involved in developing the sliding scale at Responsible Steel. Going back to some of the earlier questions about the progress levels and is there availability, there's no point in asking for something that doesn't exist, I mean, crudely. But the level 1 progress level is aimed at being better than average. I mean, that's what that is trying to do, that first sloping line. So on that basis, half the world's steel should be below that line, progress level 1. So I suppose it's a question for the panel. Any thoughts?
Michael, Sabine?
I'm happy to start. Yes, of course, also very well aware of that we're looking at global averages, so about 50% of steel should be below progress level 1, and which is what we are also emphasizing through the dual decarbonization approach, is that whole shift downwards. So, if you're looking at individual steel sites, individual steel making processes, what's the process emissions and how can we support through the demand signals, through project specifications in asking for that reduction in process emissions from where it is today going downward on the line. And that's exactly what's kind of crucial, is that if it's not available today, we've had this discussion at the very kind of beginning of even the Steel Zero initiative being set up, and the whole purpose of this demand signal was that industry saying that there's no demand, why should we begin decarbonizing, and then the demand side saying there's no supply, how can we specify and how can we ask for it? And that is why we're tackling it from both sides, right? We are working on creating the demand signal for that future demand and sending there's very clear messages to the steel industry, to policymakers, to everyone. And of course, on the steel industry side, through the development of standards and certifications, harmonizing definitions, we're kind of coming together at a global scale on what exactly is needed to decarbonize the steel industry. I know I've kind of gone very far away from the thought that you shared, but that's the power of having these conversations now, coming together and being very aligned with what we are all starting from, and then taking that forward.
Michael, do you want to add anything?
Just quickly then, I mean, I share the view that the whole paper's about constrained scrap. There's no point in specifying some low carbon steel that isn't available either. That would be crazy. So yes, for me, although I'm fully behind the approach, I do think the progress levels and the timescales, I'm thinking of Steel Zero timescales, need to reflect some of the issues that Ben's raised. So, there's no, I don't think, personal view, having a one-size-fits-all for what these progress levels are in different parts of the world, because rightly or wrongly, politics and security and economics in the UK context are going to trump, that's a Freudian slip, wasn't it? Are going to sort of supersede probably some of the carbon arguments. I mean, clearly we need to do both. We want a strong UK economy, but we also need to think about how we decarbonise that. So yeah, I think we do need to think more about those levels and where they sit, and I think they probably need both some adjustment, shall we say, and that will be tricky to get agreement on that adjustment sort of vertically, but also adjustment in terms of timelines.
Probably got time for one more, so lady down the front.
Thank you. Kemi Owoye, Wilmot Dixon, Technical Lead for Sustainable Design. I wanted to ask, what is your advice for us in the short term? I'd say 1 to 3 years. If we have electric arc steel coming to the UK in, say, 5 years, in the meantime, we have customers who are asking us to give them low carbon steel. We are under competitive tender conditions. Can you do it? Yes, we can. But if we do what you are asking, we either risk failing our customers by not specifying getting the lowest carbon steel we can, or we fail the global objective because we then go to higher, lower carbon steel. So what's your advice for us? Because the other thing is money tends to be a determining factor at that point, and if they feel they can get it cheaper, they will go for the cheaper option?
I think I would start by saying that having that conversation as early as you can to say, what do you mean by the lowest carbon steel? And do you mean something that aligns with this dual decarbonisation approach and therefore is lowest carbon for a given amount of scrap? Or do you just mean lowest carbon? Because we know that doesn't happen in global scale. That's a conversation that needs to be had early. And for a lot of your projects, that moment may have passed, right? In which case, it's a case of having that conversation with those clients, with those asset owners, developers, whoever it is, to say, look, on the next project, we need to think about this. We need to get it in there. And then when you do have the opportunity to influence, because you are asked about this early enough, to say, we can get you the lowest carbon steel within the given percentage of scrap, we can approach it from this dual decarbonisation perspective, and to put your approach in based around that, rather than just accepting, we need to hit below a certain number. It's a certain number for a certain amount of scrap. And I think that if, that would be the sort of approach that the industry could take on this topic in general, that would align with the dual decarbonisation approach. And if we have enough thinking like that, then hopefully what will happen in time is the tenders you'll receive in the first place will word it in that way rather than just saying, give us steel that's below X. I hope. Probably still have time for one more, given that that was a fairly neat question. Thank you.
Thanks, Chris Price, Max Fordham, and they're both two names. Max Fordham's company.
Chris Price, Max Fordham.
That'll work. I'm actually going to come back to something somebody mentioned, because I do think it solves all these issues, which is that we should be using average factors at stage 5 and not product specific. Because right now, we do a lot of net zero carbon jobs, so trying to get net zero carbon, we hit stage 5. We have to then do this bizarre procurement route where you've got to try and find this blended rate, or you have to go EAF to meet this average factor we were using before. I think it's a great factor. Now, whether that's consumptive average, regional average, or ideally global averages, if you're kept using those and those factors get updated every year based on EPDs and market supply, you get judged on how little you use, which is kind of the underlying message of all this, which is use less, not spec your way out of it. But without being allowed to use average factors past stage 5, you're stuck in this frustrating loop of having to do this to hit any target, any badge. I know it's a rigs problem, really, not you guys' problem, but I just kind of want to hear your if you think that we definitely should stick with go stage 5, you go exactly what you bought route rather than average route.
I think our view on this would be the first thing you have to do is remember why you're calculating the embodied carbon of these designs in the first place. And it's to try and reduce it rather than just to work out what the number is with the most precision possible. And so the reason the institution advocates, at early stage of using generic factors is because it tells you what you're probably going to get onto your site in different materials based on supply chains that we know feed into the UK or whatever region you're working in. And therefore you're probably, you're going to increase the likelihood of making the right decision as to which material goes where from a carbon perspective. Once you've locked in that design with those materials and you've said this is definitely a concrete frame with a steel frame above it and there's some timber here and bricks and so on, really then all you can do is to make those elements of design as efficient as possible. And if you've got steel work in your design, then the tonnage of steel, how can you get that as low as you can? And it sort of doesn't matter what carbon factor you put on it at that point in time. It's how do we use that as steel as efficiently as possible. There are, of course, reasons why you would be asked to calculate and submit a whole life carbon assessment of the projects at the end. Maybe it's for planning, maybe it's because your clients asked you to, maybe it's just for your own records. But the fundamental reason to do it in the first place is to minimise emissions. And so I think when it comes to, do we use a generic factor late on or do we use the specific one? Ask yourself that question with respect to, will it help me to decarbonise this design?
Can I sound a little bit? I mean, don't get me started on the RICS PS, but we've touched on those. There are three, I think of it in terms of three levels. There are project levels where you're trying to specify stuff. There's a national level where we have legal commitments and we're committed under the Paris Agreement. And then there's the global stuff, which we're mainly talking about today. For me, the big challenge is consistency. So when we see the results of this steel strategy, we need a national policy that doesn't conflict at those various levels. And that is going to be the challenge. But we need to get this policy set first, and then we can think about, well, what do we do about Part Z and the UK Net Zero Carbon Building Standard to align them. I fully support measuring at project level, and clearly we've got national commitments as well, but we do need a coherent government policy that addresses the project, the national and the global level. And just quickly back to the question before, for me, the main thing for clients is please educate them about this. I think that's the main message of this. We can get into all the detail if they're interested. They've probably got bigger fish to fry. But if you can just take this and have the dialogue like Arup, like Ramboll are doing with their clients, I think that would be my main message.
So with that, we are officially out of time. For those still in the room, there is tea and coffee and pastries and things upstairs, and we will be around. Some of the other authors are present as well, so if you want to ask more questions, please do, but we'll take that conversation upstairs. So those online, we won't be shipping you any tea, coffee or pastries, I'm afraid, so please go get your own. I think just a couple of sort of final thoughts. You've heard again and again, please share this document with others. Talk about dual decarbonisation with your clients, with your collaborators. You've also been given flyers with some free steel guidance, so please download that and look at that and look at our website for more on that topic. And please continue this conversation, both with us and with the wider industry. So thank you for coming today. Thank you for your time.